Okay. Potential difference, the definitions actually is work done per unit charge, right? Work done in driving one column of charge from one component to another component. Okay, so dear here, this V is W over Q. W is the energy. Energy is work done. Work done is energy. So you have to think again. Okay, break again. Okay, for this part, break again. Force times distance, Fs, divided by Q is the charge. Okay, for Q equals to IT. Charge, Q equals to IT. So the previously, all the formula you have, you still need have all these formula in your brain. You cannot just finish your IGCSE then you throw away. Teacher, what is Q? Q is what? Q is charge. What is the formula? Formula Q equals to IT. Okay. So at here you have to break again. Then you have to break. Force F equals to MA. Then times distance. Then times I times T. So you have to continue break until you're able to get the SI base unit. Okay, for example, at here, mass is in kg. A is acceleration in ms negative 2. S is the distance in meter. Okay. So at here divided by current is ampere. The time is in second. Okay. So at here I will get kg m square s negative 2 divided by as. So at the end for the voltage I will get kg m square s negative 3 a negative 1. Okay, until this step, do you have the idea? Without referring back just now our worksheet, can you continue breaking the physical quantity, break until at the end you able to get the SI base unit? Now this one is the SI base unit for voltage. We haven't complete resistance unit. R is equals to V over I, right? So the unit for here, V is kg m square s negative 3 a negative 1 divided by I is area, I is ampere. Okay, I is ampere. So at here, it should be kg m square s negative 3 a negative 2. So your answer should be A. Do you able to get the idea on how we find the SI base unit without memorizing? Okay, no, don't trying to memorize, impossible. How you memorize all this such thing? Okay, all such thing, how you memorize? So the technique that we can solve this kind of question is we need to find the formula and then we start to break it. Okay, V voltage is equals to W over Q. Then what is W? Work done. Work done is force times distance. What is force? Mass time acceleration. Okay, MAS, so kg meter per second square, then times meter, something like this. You continue until the end. So until the end, please make sure you see kg is SI base unit, M is SI base unit, S and ampere. Okay, so it's the 5 SI base unit, all is here. Okay, so answer is A. We will get answer A. Until here, any question for the first question that I guide you? Is it okay? Yes, good job. Okay, dear, here, we try with another one. If I didn't guide you, do you able to get it? Try. Okay, power like this. What is the unit, SI base unit for this symbol? Okay, so my suggestion is I will rearrange the formula first. So like this, rearrange. So P divided by A T power of 4. P is power. So dear, you need to break it down. Power equals to E over T. Okay, then you continue break down. Then A is the surface area. Surface area easy lah, meter square. T is temperature. Temperature should be SI base unit for temperature should be in Kelvin, not degree Celsius. So right now your task is you need to try how you are going to break this until you're able to get the SI base unit. Because area is in meter square already, SI base unit, temperature is in Kelvin. So now your task is the power. Okay, you try before I give you the answer, and then if you're able to get the answer, then you let me know. Power, we can break it, become P equals to energy divided by time. So what is the energy? Energy is work done. W, W equals to Fs. Okay, so you can break until Fs over T, then F is Ma, so Mas over T. 润兄, yes, very good. You get the answer correct. You can try with the third question. How about others? 润兄 already get the answer. Changyu, Yanni, Yuan, Victoria, Wisha, Shanice, Additional, Coco. Correct, Additional, correct. Now only two of you finish question 2. You have to respond to me so that I know that most of you able to solve. Then we can continue with the next one. Okay, so as I told you, power I can think about work done divided by time. Work done is force times distance divided by time. Force is MAS divided by time. So from here I can know the unit. kg ms negative 2 times meter divided by time is in second. So I will get kg ms negative 3 m is square. M is square. So I will get kg m square s negative 3. So do substitution at here. Kg m square s negative 3 divided by m square. Then Kelvin power of 4. So m square and m square up and down we can cancel. So we will get kg as negative 3, k negative 4, power of negative 4. So answer should be B. Okay, answer should be B. Is that clear? This is step 1. Here is step 2. Final answer. Is that clear? Okay, good job, dear. Good job. Okay, here. Can you try? Unit is joule per kg per Kelvin, but joule is not in the 5 base quantity, 5 base unit what? kg yes, Kelvin yes, but joule no. So you have to think how to solve the joule in terms of the SI base unit. Okay? Junxiong, correct. Good job. Correct, correct. How about others? Joule. Joule is the unit of what? Unit of energy. So you have to think energy, you can choose whatever. Energy can be a work done what? Energy is work done is energy. So it's Fs MAS. You see? Settle already. What is the unit? Base unit. I got you until here already. Can you continue? MAS. Convert. Write the base unit for the mass in terms of kg. A ms negative 2. S is in m. So it's kg m square s negative 2 for joule. Joule actually is this. Okay, in terms of SI base unit. Yuan answer. No, Yuan. Yuan, this part, is it okay? This one, Joe. Did you able to get this? Joe is in term of kg meter square. Yeah, you get this. So we see what is the problem. Kg m square s negative 2 times kg negative 1 times Kelvin negative 1. So Yuan is here. M kg cancel per kg. Kg cancel per kg. So it will be m square s negative 2 k negative 1. I think it's careless. If you able to get Joe same as me, actually the rest should be not a problem. Okay. C correct, Adelshina. Shanice. C correct. Good job. Okay. There we go to page number 7. Is it okay? Okay, let's go. Page number 7 here. Uh, which one is the base quantity? Kg mass. So kg is mass. Mass is base. Yes. Tick. Mass. Yes. Then 1 meter. Meter is length. Here no length is okay. 1 ampere. Ampere is current. So this is current. Yes. Base quantity. 1 second is the time, no time. 1 Kelvin is temperature, no temperature, so it's fine. Current and mass in this table is base quantity. The rest is not base quantity. For example, energy in work done actually is force times distance. Can you see that is something multiply? Okay, some physical quantity that we multiply together, like it's derived unit, it's derived, it's not base quantity. Force is equals to MA, okay? Derive how we say combinations of from the base quantity. Okay, here use the definition of power to determine the SI base unit. Power definition said that rate of change of work done. Rate of change of work done. This is the power. Okay, work done per time. This is the definition. So from here, can you derive the power SI base unit? Can you try derive? And then what is the unit here? So work done. Again, work done is Fs. So we can also say MAS divided by time. So the unit SI base unit should be kgms -2 times meter divided by second. So it should be kgms -3 m squared. Okay. If you step by step, do you able to get the same answer as me? Kg meter square, then second power of -3. Okay, is it okay for this? Yes, Junxiong okay. How about others? Okay, Shanice okay. Adishina okay. Changyu okay. Coco okay. Good job. Like here, we comes to next question, number 5. So this one is drag force formula. And then they tell you that K is a constant value. Constant value doesn't have unit. Constant, oh, God. They ask you to derive unit. Okay. A is the cross-sectional area, so it's area. Okay, they want you to find K. So for me, I will rearrange, but you don't want to rearrange also, never mind, up to you. Okay, FD divided by V square A. Okay, deal. You need to derive. But the problem is FD is the force. Force in Newton. Newton is not SI base. So you need to continue, break it down. F equals to MA. Then you do writing down the SI base unit. Then V is speed. So you know the speed one, right? MS -1. Then area, meter square. Okay, can you continue? 10 seconds. You proceed. And I also writing my answer. Then after that, you check your answer. Okay? Okay, this is my final answer. Do you able to get and do you able to get this answer? Yes, Junxiong, yes. How about others? Only Junxiong get the answer? The rest of you? Which part you're facing problem, you let me know. Shanice okay, Changyu, Yenny, Coco okay? That is the technique. Yeah, we break down, break down, break down. So if you understand how to solve the question, you no need to memorize. Physics is not about memorizing, dear. Changyu. Yes, okay. Dear, okay, then we goes to page number 8. Right now, we goes to page number 8. Okay, what is the mean by work done? Year 10, we learned about that. Okay, work done is what? Is the force time displacement in the direction of the force. Okay? Okay, can you using this W equals to Fs in A? This is what we say. Can you show that SI base unit of energy actually is kg meter square s negative 2? Okay? Energy is what? Energy is work done. Work done is energy. Can you prove W equals to Fs? Then continue. You able to get the SI base unit for the work done? Is kg meter square s negative 2. Can you prove? Prove it right now. Okay, settle. Okay, settle. So should be not a problem, because just now we proved a lot about the energy and work. Okay, here we comes to the next question. C. Can you try? At the same time, I also try that, okay? So you try it right now for the question number C. So at the same time, I also writing down my answer so that on you can check. So what they want, SI base unit of C. So if I rearrange the C is equals to EL divided by CA. A T1 minus T2 times T. Okay, start from here. E is energy. Energy, do we need to re-derive again? No need. In B, question B, we already have work done is energy. Energy is work done. So just now the B kg meter square s negative 2, we already have it. Energy is already have, we already did calculation and proved the energy SI base unit. So L is the length. So length is in meter divided by area. Area is meter square. Then T1 minus T2. This is temperature. Okay. Mostly students will make mistake at here. T1 minus T2. What is the unit? Okay, let's say I told you 10 Kelvin minus 2 Kelvin. How many Kelvin? Answer is 8 Kelvin. Am I right? 10 Kelvin minus 2 Kelvin, you get 8 Kelvin. So actually at here, this is Kelvin. Okay, a lot of students, I can't remember, they say they write 2K, something like that. They write 2K or they write K squared, something like that. Okay, but actually is 40 degrees Celsius minus 20 degrees Celsius, you get 20 degrees Celsius. So final unit is degrees Celsius, right? That one is degrees Celsius, I mean Kelvin. Okay, 10 Kelvin minus 2 Kelvin. What is your answer? 8 Kelvin. Kelvin, only 1K. Then T is the time, right? Let me have a look. Not T. Not T. T. Yes, T. T is the time. S. Okay, so unit. So at here, kg m qs negative 2 divided by m square Kelvin second. So at here, it become kg m, then s negative 3, k negative 1. Okay, this is the final answer. kg ms negative 3, Kelvin negative 1. Anything I need to explain or any things that you confuse, let me know. If you're able to get the same answer as me, then you give me some reaction so I know that we can proceed. Junseong okay, Shanice okay. Only two, okay? Okay, Changyu, okay. Okay, good job. Coco, okay. Dear, that means that we overallly we okay. Not okay, you also can rewatch the video, okay? The video recording. So page number 9, come here. Homogeneity of equations. The equation must be homogeneous. This one is very important. If you cannot get a homogeneous, that means that this equation is wrong equation. Sometimes it helping us. Sometimes teacher, I can't really remember the formula. Is it v equals to u plus at? You don't know, you forget. Is it plus or negative? V equals to u plus at or equals to u minus at? It's okay. You can using this to prove. If the equation is correct, both sides, their SI base unit should be the same. Okay, for example, this equation, we want to know that valid or not this equation. T square unit is S square because period time. So it's second square. Then 4 pi square. This one 4 pi is a constant value. This one is constant value, so no unit. Constant value is a value. So no unit. Okay, don't bother about it. Length is in meter. G is gravitational acceleration, so it's ms negative 2. So at the end, m and m cancel, we get s squared. Left hand side s squared, right hand side s squared. So this equation is a valid equation. Is that clear? Okay, then we try with the partial question here. Frequency. Then C is a constant with no unit. C is a constant without unit. M is the what? N is the mass. K is a spring constant. Okay. K is a spring constant. Okay. Frequency. What is the unit for frequency? Hertz, right? We will also say, teacher, hertz. But hertz is not the SI base unit. Okay. Then how? Frequency is 1 over period. So actually frequency unit for frequency is S negative 1. S negative 1. Okay? C is a constant without unit, so we ignore it. M is the mass, so in kg power of P. Then K is a spring constant. So what is a unit, SI base unit for spring constant? So you have to know the formula of spring constant. F equals to Kx, Hooke's law. So K is actually F divided by X. So from here, can you continue proceed until you able to get the what? SI base unit. Force MA divided by X. So it's actually unit for K is kg ms negative 2 divided by x is a distance, so m. So it should be kg s negative 2. So at here, my k should be kg s negative 2 power of q. Okay, until this step, do you able to get the idea? Mass in kg, but spring constant, what is the SI base unit? So you have to continue derive, and break. At the end, you get kg per second square. Okay, then after that, solve it. Kg power of P times kg power of Q, then times S negative 2Q, S negative 1. Okay, until here, it's just mathematics. What is the P? What is the Q? Okay, so at here, left hand side, we got second per second, okay? So at here, using my highlighter, can you see that this one and this one, they must be the same. They must be the same. If this formula equation is valid, so they must be the same. So at here, negative 1 equals to negative 2Q. So Q actually is 1 over 2. Is that clear? Then with the Q, then how about the P kg part? Kg part. So P plus Q is actually 0. Kg part, I using blue color to highlight this one. Okay, so this part. So at here, P we don't know, but Q we already 1 over 2 equals to 0. So P is negative 1 over 2. Answer is B. Is that clear? It's your mathematics. Good job. How about others? Do you able to follow? Okay, can I? Oh, everyone okay. Good job. Like there we goes to the next. Prefix. Prefix is very important in our physics. And they always like to using prefix in your year 12. Okay. So tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico, all the value you have to know. Okay, but nowadays you are very lucky because your calculator, most of your calculator calculator can help you. Okay, most of your calculator actually can help you for this part. Okay, here tera is 10 power of 12. Okay, if your calculator got that, I teach you, this, let's say this is your calculator, this is your screen. If not mistaken, I don't have the calculator, but I can remember. It's roughly somewhere here, there is called OPTN. Okay, you press 1, you press 1, then after that, you press OPTN option. OPTN is on your left hand side option. Then, if not mistaken, you press number 3, which is showing engineer symbol. Engineer symbol, number 3, if not mistaken. Okay. After you press the engineer symbol, you should able to saw all these prefix T, G, M. So can you help me? If you got that calculator, can you help me? I don't have. So can you help me? Press until 3, engineer symbol. T is what number represent the T? They're asking you to press. Can you let me know? Look at that. Press 1, press OPTN, press engineer symbol, which is number 3. So from your calculator, after you press the engineer symbol, the T actually is one number because I don't have the calculator. Junseong is 9. Okay. So press 9. Let me have a look. Shen is 9. Yes, thank you. Changyu, it says syntax error. You press 1, press OPTN, press 3 until which step you got syntax error. Okay, press 9. After that, you press equal. Then they will help you and show you what is your T value. It should 10 power of 12. So the rest of you able to get it? Okay, do the same technique. Press 1, press OPTN, engineer symbol, then choose the symbol. Then for giga is 10 power of 10. Sorry, 10 power of 9, 12, 9. Then 6, then 3. Okay, then here milli is 10 power of negative 3, 10 power of negative 6, 10 power of negative 9, 10 power of negative 12. Okay, deci and centi is 10 power of negative 1, 10 power of negative 2. Changyu, you get it, So dear, if your calculator have this function, you are so lucky, okay? But CMRC, this one is not in the calculator, the engineer symbol, you have to know lah. But we already know what 1 cm actually, how we convert to meter divided by 100 is actually 10 power of negative 2, okay? Okay, dear, here. What is equals to this value? Okay, if I move 1, 2, 3, 4, 5, 6. So that means this is 5 times 10 power of negative 6 joule. Am I right? I move backward. So need to put a negative. Okay, the value becomes small. It's a very small value. Okay, A, B, C, D. Which one will be having the same value as 5 times 10 power of negative 6 joule? So try it. Shanice, yes, correct. Shanice say answer is C. Because 10 power of negative 6 is micro. Here, micro, 10 power of negative 6. So answer should be C. Without calculating others, I already can know answer is C. Okay? Next deal here. Expressing an energy 43 deci. Ask yourself, deci is 43 times 10 power of negative 1 joule. So it's answer 4.3 joule. So here you have to continue, do conversion. And then try A, B, C, D. Which one also get 4.3 joule? Okay, I'm done my part. Do you able to get the answer for question number 2? Answer A. Is it okay for question number 2A? So you need to know the prefix. Is it okay? Yes or no? Yes, Shanice, yes. How about others? Okay, Changyu, okay, so we proceed. Okay, Junseong, okay. Okay, dear. Like dear number 3, what is the ratio for 10 power negative 3 tera divided by 10 power 3 kilo? Okay. Do it right now. At the same time, also doing. Question number 3, answer should be D. Here is my working step. Is it okay? Yes or no, dear? Yes. Okay, So, dear, how about this? Changyu, Yanni, Jet, Junxiong, okay. Shanice, okay. Changyu, okay. Yuan and Yuan, Coco, able to follow? Junxiong, okay. Coco, okay. Okay, deal. The behind one is called self-practice. All the question below here. Oh, I forget to provide the answer. Okay, it's okay. Can you write the final answer here? Self-practice normally at the bottom part, I will provide the answer. So you do it by yourself, practice more. Then after that, if you're really facing problem, then you can WhatsApp message to me. I will show you the working step. Okay, so here, can you write down the final answer? C, then number 2, B, number 3, D. Okay, write down. Then we goes to the page number 12. CBD, CBD. Okay, next page, page 12. Here, answer is C. Number 4 is answer C. Number 5 is for the prefix here. Number 5, Number 5, no need lah. You can check at the front. If I write, then already write the answer at here. Okay, number 6 at here. Why I didn't? Oh, number 6 I got provide answer here. Number 6 answer is here. Okay, just this one. Number 5, maybe we complete it lah. Okay. So this one nano. Nano pico. Nano is the last two. So it's 10 power of negative 9. Okay. How am I memorized? Can you see there is a sequence dear here? 12 minus 3 become 9. 9 minus 3 becomes 6. 6 minus 3 become 3. Okay, then this one negative 3 minus negative 3, negative 6, negative 9, negative 12. Only these two is negative 1, negative 2. So actually for me, I remember the sequence and I know 12, 9, 6, 3. Then negative 3, negative 6, negative 9, negative 12. So nano pico, I know that is negative 9. Okay. So for this part, nano is negative 1, negative 9. Centi symbol is C. Then M is mega, mega. Okay. Then T is tera. That's all. So tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. Okay, last time my calculator not that nice, so not that advanced, not nice, not that advanced. So we have to memorize all. Okay, dear. So basically, self practice is for you to practice whatever we already learned today. Okay. Then I want to go to worksheet number 2. Is it okay? Okay, Junseong, okay. How about others? Coco, okay. So we proceed, Okay. Okay, worksheet number 2, errors. Okay, random and systematic error are two types of measurement error that will cause uncertainty. So before we learn how to calculate the uncertainty, we have to know what kinds of error causing this problem. Okay, random and systematic. So systematic error, you will find out that all the reading they will together, they shift. Okay, either is larger than actual value or either they will be smaller than actual value. Okay, for example, actual value should be like this. This one should be the actual value. Okay, actual value. But at the end, true reading lah. Okay, true reading. True, where True reading, it should be like this line. But at the end, you found out that when you plot the graph, you do measurement, this is your reading. Measure reading, okay? The reading that you measure. Okay, you will find out that no matter how many times you repeat your measurement, all the value will be higher, larger, or smaller than the true reading that we supposedly have. Okay, for example, let's say I got a object. Okay, I already know that this object is 4 cm. Let's say 4 cm. Then you use your ruler. At the end, no matter how, you tell me, teacher, it should be 5 cm. It should be 5 cm. Then must be something wrong. Actual reading is 4 cm, but you repeat for many times, it's still 5 cm. You repeat, ask your friend how you to measure. Your friend also using the ruler, say, teacher, this is 5 cm. Then what is the problem causing this systematic error? What is the reason? Okay, one of the reason is maybe the fault in the apparatus. Maybe the ruler that I provide to you here is 1 cm, 2, 3, 4, and 5. That's why you keep on telling me, teacher, this object is 5 cm. Is it 5 cm? Then you change another friend using this ruler, you still getting 5 cm and told me 5 cm. But no. Okay, so this is maybe because of the apparatus problem. Okay, apparatus is already wrongly calibrated, okay, or something wrong. So here, can we repeat the experiment, repeat the measurement to reduce this systematic error? My answer is cannot be eliminated by averaging. You repeat and then average, can or not? Cannot, because your apparatus problem, no matter how many times you repeat or you change another person to repeat, measure it, you still get the problem. You're still getting all the reading which is slightly longer or slightly higher or slightly larger than the true reading. Okay, so at here, maybe it's apparatus problem, or maybe you keep on using the wrong technique. You don't know that you have to start from measure from zero. You just simply put from somewhere else, then you do measurement. Okay, maybe it's your technique problem. Okay, so one is apparatus problem is maybe got zero error. Maybe look at this spring supposedly it should be start from zero, but maybe from time to times student pull it at the end the spring spoil or whatever. Okay, so at the end you found out that no matter you haven't hang anything it already start to showing this is one. Okay, 1, 2, 3, 4, yes, this is one. Okay, so let's say I hang an object. This object is 4 Newton or 5 Newton. Okay, dear. Let's say this object, we hang something at here. This object, I know that is 4 Newton. It should be hang and show at here. But because you using this apparatus, we still hanging with 4 Newton. But in this apparatus, they will show you 5 Newton here. No matter how many times you repeat, you continue with 5 Newton, it's showing you 6 Newton. You continue with the 6 Newton object, it's showing you 7 Newton. So can you see that? There will be reading will be larger than the true reading is because by a constant amount is because of the apparatus problem. Okay? Zero error is the error due to the apparatus when not in use, it doesn't show as zero. That is called zero error. Okay, so this one will affect the accuracy lah. Okay, accuracy. So how we reduce? Recalibrate. Make it readjust until it's starting from zero. Okay, recalibrate the instruments. And then the technique that you use should be correct lah. Okay, can we repeat and then take average to reduce this systematic error? My answer is cannot. Because no matter how you careful, how you repeat for how many times, you still have this error. Okay, until here, is that clear for the systematic error? Okay, so we go to page number 2. Random error. Random error, here, highlight. Okay, schedule. The reading, this line is the true reading. This line is the true reading. This line is the true reading. So it will scatter surrounding it. Okay, this one is maybe the observer, maybe you get a slightly different reading. Okay, every time you observe, then maybe it's because of the environment, maybe because of the pressure slightly change, temperature slightly change lah. Okay, uh okay, then here example is reading scale from different angle. Okay, maybe slightly from different angle, so we get the reading is scattered at the line, around the line. Okay, wrongly interpolating between the scale reading and division. Okay, then what else affect the precision? Okay, later on we will learn what is precision, maybe next lesson. Okay, here this problem is we can solve it by we repeat it and then take average. Repeat the measurement, take average can reduce the problem, can reduce the, this is called random error. Okay, what else? Is it okay? Can you differentiate out between the random error and the systematic error? If yes, then we are going to the past year question and try. Is it okay? Okay, here, a set of repeated measurement is made of a fixed quantity. An average of this measurement is calculated. So you repeat the measurement. What is the effect of averaging on the random error and systematic error? Averaging. Both can be reduced or both cannot be reduced or one of them can be reduced. Okay, so systematic is might be due to is due to the zero error, due to the apparatus. No matter how many times you repeat, it doesn't help to reduce the error. So actually at here, both can reduce, no. Both are unaffected, no. So random can be reduced but systematic cannot, yes. This answer C. Okay, random error is maybe you slightly from different angle. Okay, so if you do for a few more, repeat for a few more measurement, it can helping you to reduce the problems. Okay, measurements of a physical quantity may be subject to random errors and to systematic errors. Which statement is correct? Okay, systematic error cannot be reduced by adjusting apparatus. Is it correct? No. Systematic can. Systematic, one of them is the zero error. You adjust the apparatus until it showing zero when not in use. Okay, it should showing zero. Zero error meaning that it doesn't show as zero. So we have to adjust it. Okay, systematic result in a different reading each time. Each time different reading. the measurement is taken. So no. Okay, systematic, you see, they will be larger or smaller at a constant amount. Okay, they didn't show different reading. Every time we repeat, we're still getting the same answer. Every time you measure this, you're still telling me, teacher, it is 5 cm, but no, it's 4 cm. Okay, so at here, B is also wrong. C, random errors always caused by the person taking the measurement. No, can be caused by environment. What? Temperature, pressure. Okay, random error can be reduced by taking the average. Yes, answer is donkey. Okay, can we proceed to the page number 3? Yes, Junxiong, okay. Question is okay. Okay, like dear, here next. Figure 2.2 shows variations with T of V. Okay, name the feature. What is the features that indicates the presence of random error? Okay, based on this graph, I told you it has random error. How you know? How's the graph show you this characteristic? So random error here, scatter in reading. Can you see that? In the true reading here, the point is scatter at here. So from here, I know it has random error. So at here, how I know random error is there is because of the scatter of points about line. Okay. How I know there is a systematic error? How I know, dear? Systematic error, one of the error is zero error, right? Can you see that systematic error at here? Supposedly starting from 0. But you will find out that it will be the reading that we measure will be larger or smaller by a constant amount. Can you see that? Constant amount. So at here, we can say that how I know there is a systematic error because the graph, it doesn't start from 0. It doesn't start from 0. It's starting from somewhere, some value, okay? So at here, this one, we can say that the line does not go through origin. Okay, you write down. If done, you give me reaction so I know that we can proceed to the page 4. Okay, let's go. Precision and accuracy. Okay, precision is determined by the range of measurement. Precision is how close the measurement together to each others. This is called precision. If high precision, that means small range. Okay, they are gathered together. If they are gathered together, then we say that this one is precise. Okay, precision, high precision. Okay, accuracy is how close to the true value. Okay, how close to the true value. This one precision is close to each others. It's different, So we look at the example number 1. This one, they are far away from each other, so this is low precision. Then they are far from the center. We want to hit at the center. Center is our actual what we want, but it's far, so it's not accurate. Second one, they gather together. So this one is high precision, but they are far from the center. So this one is not accurate. This is around the center, so it's accurate, but they are a bit far from each other. So this one is low precision. Then the last one is they gather together, then also they gather at the center. This one is high precision and high accuracy. Okay, so here Systematic error. Systematic error is, for example, just now the zero error. So I ask you to measure the object is actually 4 cm, but you keep on telling me, teacher, that is 5 cm. So it will affecting what? Affecting the accuracy. It will far from the true value, okay, from 4 cm. Random error is what? The reading is scattered, the point is scattered, so it's far away from each other, the point, so that is affecting the precision. Zero error is actually under this systematic error, is the example of the systematic error, so it will affecting the accuracy. Okay, until here, is that clear? Okay, Shanice, okay. Okay, good job. Okay, dear, here. Student takes several measurements of the same quantity. This set of measurement has high precision but low accuracy. What is the meaning by high precision? Answer is here. High precision, they have small range. Okay, wait, like this. Okay, small range. You just copy lah. Okay, measurement have a small range. What does it mean? Okay, for example, object is 4.0 cm length. Okay, the length is 4.0 cm. So you measure 4.1, you measure 4.0, you measure 4.1, you measure 3.9. So actually this one they are small range. They are quite close to each others okay. So it's not like 4.0, then this one 5.0, 3.50, then 5.5, something like that. This one is very far from each others, okay. So if high precision means that they're having small range. The range is from 3.9 to 4.1. This is the range. The range is so small, okay? So high precision is this meaning. Low accuracy means that the measurement is not close to the true value. Is far from the true value, then it will be low accuracy. Okay, is that clear? So if what is the meaning by low precision? Then you say the measurement with the large range. What is the mean by high accuracy? Measurement is very close to the true value. Okay? Is it okay? Can we proceed to question number 2? Okay. Okay, dear, here. Can you try with question number 2? And then at the same time, I take attendance one more time again because just now maybe it's incomplete. Corina is not here. Joshua is not here. Okay, the rest of you are here. Hmm? Tell me your answer. Oh, wait me for sure. Okay. Okay, let me have a look. Corina. Oh, Coco is Corina. Okay, I see. Thank you, Coco. Okay, can. Junxiong, correct answer. Shanice, correct. Adashina, correct. Okay, dear, here answer is donkey. Okay, because the value is quite close to each others, they're having small range. They close to each others are small range, or we say close to each others. Okay, then not accurate. Why not accurate? Because the actual reading, okay, true reading is here. True reading is actually 42. But here, all your measurement is 48, 47. So answer will be D. Okay, it's far from true reading. Far. Okay, question number 3. Okay, have you done question number 3? Chinese. Correct. Answer is donkey. So dear answer is donkey. So this one is precise. Yes, they're close to each others. Just plus minus 0.1. Okay, because 80.1 and 80.2 plus minus 0.1 kg. So not accurate is because your actual reading is 75. So this reading is far from 75. Okay, so it's not accurate. Answer should be donkey. Junxiong, correct. Okay, like dear, one more question before we end our lesson. Okay, can we proceed to the page number 6? Can we proceed to the page number 6? Yes, okay, dear, here. Can you try before we discuss? Victoria. Oh, Victoria is here. Jay is here. Ting Wei. Okay. Okay, dear, what is your answer? Last question. Tell me your answer. Only Shanice give me. How about others? Shanice, your answer is correct. Adashina. Almost there. One correct, one wrong. Try again. Adashina. How about others? Junseong? Last already. Tell me your answer. Last question. Before we end our lesson. No, Junseong same as Adashina. Okay, dear. Here, V is the actual true value. True value, V is actually true value. So this one is here. So that means that this one is accurate. Yes, accurate. Okay, precise. Precise, that means they're close to each others. Are they? No. Can you see that? They spread out. They spread out. So this one not precise, low precisions, but high accuracy. Okay. Then for the Y, this one they gather together. They gather here, gather together. So it's high precision, but not accurate. Why not accurate? Actual value is here, so not accurate. Okay, for the Z at here is gathered at the center, and then also at the exactly at the V actual reading. So it's precise and accurate. Yes. So how many? A, this one and this one, two. We got two accurate. Okay, too accurate. And then here, precise P, we got 2. So answer should be donkey. Okay, answer should be donkey. Adashina, yes, correct. Okay, so next lesson, next week, we'll continue uncertainty, continue this lesson, and the lesson number 3. Okay, any question? If no question, we will end our lesson right now.